Good morning. My name is Phimmada I'm from พระปฐมวิทยาลัย School. Today I would like to present about doped silica monolith as an ammonia optical sensor. My supervisor, Assistant Professor Dr. รัชดาบุญเต็ม My advisor, Ms. วรันพร คังคประดิษฐ์ and Mr. ประเสริฐทรัพย์มาก Topics. There are introduction, objectives, materials, methods, results, discussions, conclusions, training experiences, future work, references, and acknowledgement. Introduction. From literature reveals, the optical sensors were prepared using various matrices. Among these, silica was easily prepared, inert, stable in harsh environment, and environmental friendly. The clear silica monolith was used as the matrix for ammonia sensoring material. Objectives: to prepare doped silica monolith and to test ammonia by using doped silica monolith. These are materials. Methods. In this work, I divide the methods into two parts. Part 1. Preparation of doped silica monolith for copper monolith. Theos is used as the precursor for preparing silica monolith. Theos mixed with ethanol and copper chloride solution. Then add 1 molar of hydrochloric acid. And then add N,N-dimethylformamide or DMF. Stir for 2 hours. Weigh the salt and fill in small vial. Then leave and dry at room temperature for 2 weeks. And to obtain copper monolith. For curcumin monolith, mix theos, saturated ethanolic solution of curcumin and water. Then use the same methods as preparing copper monolith and to obtain curcumin monolith. For butterfly pea monolith, mix theos, ethanol, and extract from butterfly pea. Then use the same methods as preparing copper monolith and to obtain butterfly pea monolith. For red cabbage monolith, mix theos, ethanol, and extract from red cabbage. Then add 1 molar of hydrochloric acid. Add N,N-dimethylformamide or DMF. Stir for 2 hours. Then filter it. Weigh the salt and fill in small vial. Then leave and dry at room temperature for 2 weeks. And to obtain red cabbage monolith. Part 2. Sensor activity of doped silica monolith against ammonia. For copper monolith, add ammonia solution with copper monolith in small vial. Then leave for 15 minutes. For curcumin monolith, butterfly pea monolith, and red cabbage monolith, use the same methods as censoring copper monolith, but change the copper monolith to curcumin monolith, butterfly pea monolith, and red cabbage monolith, respectively. Results. Part 1. Preparation of doped silica monolith. For copper monolith is green. For curcumin monolith is yellow. I tried to measure visible absorption of this monolith, but I didn't get nice spectrum. For butterfly pea monolith is purple. I measure visible absorption of butterfly pea monolith, and here is visible absorption spectrum of butterfly pea monolith, but the lambda max cannot be clearly seen. For red cabbage monolith is pink. I measure visible absorption of red cabbage monolith, and here is visible absorption spectrum of red cabbage monolith. The lambda max of visible absorption spectrum is 525 nanometer. Part 2. Sensor activity of doped silica monolith against ammonia. For copper monolith, when testing sensor activity with ammonia, the color change from green to deep blue. For curcumin monolith, the color change from yellow to orange. For butterfly pea monolith, the color change from purple to green. For red cabbage monolith, the color change from pink to green. Discussion: Mechanism of solder process. Silica monolith is low temperature glass. It's what arises from solder process. Solder process is a chemical reaction that produces inorganic substances that are structured into a net. Alkoxide of silicon is a precursor for synthesis because it can react well in water. I use theta-ethyl orthosilicate or TeOS as precursor in my experiment. Solder process of TeOS consists of 3 reactions. They are hydrolysis reaction, water condensation, and alcohol condensation. The process of hydrolysis will replace alkoxide with hydroxyl group. The water condensation is a combination of 2 silanol groups to form siloxane bond and water is released. The alcohol condensation is a combination between silanol group and alkoxide of silicon to form siloxane bond with the release of alcohol. When the amount of siloxane bonds increases, the molecules are well to be sold. When the sold particles are assembled or connect to network, the gel will be formed. Proposed structure of doped silica monolith. Copper monolith. Copper will bind with polysiloxane. When testing sensor activity with ammonia, the color change from green to deep blue. Ammonia will replace water or chloride ion to form copper amine complex. For curcumin monolith, curcumin will bind with polysiloxane. When testing sensor activity with ammonia, ammonia will deprotonate to form phenolate ion, so the color change yellow to orange. For butterfly pea and red cabbage monolith, butterfly pea and red cabbage consist of cyanidin. Cyanidin is one type of anthocyanin. Cyanidin structure will bind with polysiloxane. When testing sensor activity with ammonia, ammonia will deprotonate to form phenolate ion, so the color change from purple or pink to green. Conclusions. Part 1. Preparation of doped silica monolith. Silica monolith can be prepared at low temperature using theta-ethyl orthosilicate as a precursor. Part 2. Sensor activity of doped silica monolith against ammonia. Copper, curcumin, butterfly pea, and red cabbage monoliths can be used to test ammonia. Training experiences. I get experiences in preparing doped silica monoliths, using scientific instruments, and performing scientific research. Future work. I will apply the sensor to monitor the spoilage of shrimps or fishes. I would like to thank you for IPST, DPST, Department of Chemistry, Faculty of Science, Silpakorn University, and พระปฐมวิทยาลัย School. Thank you for your attention.